I'm Hudson Kruse, and this is my project, Searching for Blunders. So Daniel Kahneman and Amos Tversky were leading scientists in the field of psychology. Daniel Kahneman won a Nobel Prize in his work for behavioral economics. He was a New York Times best-selling author, and he developed prospect theory with Amos Tversky. Now, Amos Tversky developed the Tversky Index. He was a psychological theorist, and he won the Genius Grant. So I wanted to follow in their footsteps, and so I came up with my project, Searching for Blunders, which is discovering the relative factors which influence a faulty thought process in chess. Now, I wanted to discover the causes behind blunders, both in chess and in life. I wondered, how does move number, time pressure, age, and rating affect chess players' mistakes? And how does this relate to the world away from the board? So I had a few different types of variables. The first were dependent variables. The second were external variables. And the third were independent variables. Now, my dependent variable was blunders. A blunder is a very key thing in chess, where it's just if you make a bad move, if you make a very bad move, then it's a blunder. My external variable was age, and my independent variables were rating. And in the chess world, a rating is basically how good you are at chess. And if you win against a higher rated player, you gain more rating points than if you would have won against a lower rated player. Now, my second independent variable was move number, and it's just how far along into the game you are. And my third independent variable was total time. So this one, most people don't understand that chess is a timed game usually. Yeah, you don't have unlimited time to make your moves, and the increment in a chess game is how much you gain after each move. Now, I had 4 hypotheses. My first was move number. I expected to find that in the later moves, more blunders would be made due to a complicated position. My second hypothesis was rating. Because rating is like a measure of how good you are at chess, I expected to see that blunders would decrease as you get better. And then my third hypothesis was total time. As total time increases, less blunders will be made, and I thought this would be true because you have more time to avoid making blunders. Now, my fourth hypothesis was age, and because experience is so important in chess, I believe that as you get older, you also get better. And this leads me to my methodology. I needed a game database that I could test, and I got this from Lichess. And I analyzed it using the Stockfish chess engine, which evaluates how good of a move it was that you made. And it gives you the total game score at the end. Now, blunder scoring is basically if it hurts your position by 1 point or more, then it's a blunder. Now, in this project, I used Excel a ton, and my first formula that I used was this one, where it sorts the rows into the ones and zeros, so I can get only the game score totals. But I needed the move scores, and so I used this formula to get the move scores of how good your move was or how bad. And then I used this formula to say if the move benefit was less than or equal to -1, put a 1 there. If it's not, then put a 0. I then used this formula to get the sum of all of those ones and zeros, and then this one to get the average of that cell range, so I could see the average, get the chances that you'd make a blunder. Now, this is what the data looked like in the end. It's a ton, and the thing is, this wasn't even all of it. I analyzed over 6,000 moves in this game. I had to fully automate this process, and that's what Excel was incredibly good for. Now, my first method was rating. So I checked white's rating, I checked black's rating, and then I collected that all into a couple of lists. And then I created a graph with white and black's rating on the x-axis and blunder percentage on the y-axis. I was very surprised by these results because there's no clear pattern here. And I believe that was because Lichess has an interesting way of evaluating their rating. If I win one game on there and it's my first game, then I'm going to have a super high rating. And if I lose one game, then I'm going to have a super low rating. And so, unless I've played like 20 or 30 games on there already, then the rating is going to be extremely inconsistent. So, the second graph basically shows the blunder percentage versus the difference in rating. I wanted to see here whether if you're playing against somebody 700 points higher than you, if you're going to make worse moves. I also saw there was no clear pattern here, probably because the same reasons I mentioned before. Now, my second method is move number. So I collected the move number, the amount of blunders made per game, and how many games that move was reached. I then created a statistical table like that one you saw in the one you saw previously, and I graphed it. And you can see this is the blunder percentage versus the move number. And we have the blunder percentage on the y-axis and the move number on the x-axis. The standard error bars there is basically how many games reached that move number. And if it was less, then it was a higher standard error. Now we saw that there was as the game goes on, so many more blunders are going to be made. My third variable was total time, and I multiplied the increment for the chess game and added that to the total starting time. I then collected that time and how many blunders were made per game, were made in that game, and I did all with all 93 games. I then created a graph with the blunder percentage on the y-axis and the game duration in seconds on the x-axis. And I was also very surprised by these results because there wasn't any clear pattern here. And I believe that was because even if you have 20 minutes total time, you might only use a minute of it. And that's a key thing that I've noticed before in playing against people in chess. They don't tend to use all of their time. Now, with this, there were very unreliable results, and so I wasn't able to. So that's why there's no clear pattern here. Now my fourth variable was age, and I checked. So FIDE is the top. FIDE has the top 100 chess players, and they're the official rating system. And I collected the top 100 chess players from there, got their ratings and got their ages, and then created a list and a graph. And this is what the graph looked like, and you can see that there's a very dominant set of people in their mid-20s to their mid-30s. I conclude that rating has no effect on whether the data conclude that rating has no effect on what are the chances that you'll make a blunder, and that as the game goes on, blunders do indeed increase. We saw that there will be no change in blunders with time, but chess playing ability does peak in the 30s. Now, we can learn to avoid blunders in chess and in life. Complex situations do increase mistakes, and conscious thinking can minimize those mistakes. The mind has its most potential in its 30s. I don't know, maybe we can even use that in the elections, because so there's not a minimum, so there isn't a minimum age past your mid-30s. Now, some future research that I like to do is evaluate that prospect theory that Daniel Kahneman and Amos Tversky started, and to evaluate those trades in chess. I would also like to find a more accurate rating database and also some more variables. I'd like to thank my family for all they did with me in this project and just helping me along with it.